And we're back, or I'm back. Anyway, I don't know if you noticed, but I went back and tried to make that line a little bit straighter, and it looks a little bit better, but I'll just have to leave it. So we've graphed the information in the table, and for part D, they want us to examine the graph and what conclusions can we make. So in other words, what are we noticing? And I'm sure that everybody is noticing that we have a straight line. And if you recall from the previous page, when we have a straight line, we can say that something is linear. So for part D, I'm going to say that the graph is linear. And I'm just going to note the first time I'm using this word that means we have a straight line. Something else I notice, and I'm not sure if you notice it, is that if I were to extend the line in the downward direction, it would go right through the origin. So I'm going to note that if extended, the graph would pass through the origin. Remember, that's the point 0, 0. And that will be a little important, actually very important, when we continue 5.2b next week. So more on that, but for now we're just going to note that. For part E, what point on the graph represents the unit rate? Well, remember that a unit rate is a ratio whose second quantity is 1. And we know here that we're comparing pounds of cherries in cost. And we also know from the table that 1 pound of cherries is $1.50. So our unit rate is actually $1.50 per pound. And on the graph, $1.50 per pound is represented by the point that is located at 1, 1.5. So that ordered pair on our graph represents the unit rate. Okay, on to page 27. And on page 27, we have a new relationship to look at. So the following table shows the pounds of meat on a sandwich and the calories in the sandwich. So I'm going to do what I did with the last table and see if we're always multiplying by that same number. So last time it was $1.50 times the number of pounds. So this one is not quite as straightforward. So I'm going to jump to the second column. And if I were to multiply 1 pound by 650, I would get the number of calories in that sandwich. And then if I skip over to this fourth column, half of 830 is 415. So in other words, 2 pounds times 415 would give us 830 calories. And that's enough for me to conclude that this relationship is not proportional because I just looked at 2 columns and I'm not seeing a common factor to get from pounds of meat to calories. So we will say that no, this is not a proportional relationship. And I'm going to say there is not a constant value that relates pounds of meat and calories. State independent and dependent variables. So we can still do that. And just like the last one, I think it's pretty clear that the number of calories in your sandwich is going to depend on how many pounds of meat. So we can say that the calories are dependent and we can say that the pounds of meat are independent. For part C, they want us to graph the information from the table on the coordinate plane to the right. And actually, we're only seeing one quadrant, the first quadrant of the coordinate plane, but we can graph the information. And they want us to label the axes. So I'm first going to label, remember our horizontal axis is X, and our vertical axis is Y. But they want us to use the labels calories and pounds of meat. So I can see on the x-axis that the numbers range from 0 to 5, and if I look in the table, it's pretty clear that that's going to represent the pounds of meat. So we'll put pounds of meat on the x-axis, like we had pounds of cherries on the previous problem. And the y-axis I can see goes from 0 to 1,000, and that will definitely be the calories in the sandwich. So we will label calories on the y-axis and pounds of meat on the x-axis. So that's what they mean to label. That way if somebody looks at our graph, they know what information it's showing. So now, from the table, half a pound of meat has 560 calories. So from the origin, I'm going to go over to 0.5, half a pound of meat, and then up to 560. So that's going to be just a little beyond 550. Next, I've got 1 pound of meat is going to have 650 calories. So write 1 and then up to 650. 1.5 pounds of meat, so we'll go right to 1.5. We'll have 740 calories, so we'll put that point just below 750. 2 pounds of meat, so 2 to the right on the x-axis, we'll have 830 calories. So I'm going up to 830, which will be just a little more than halfway between 800 and 850. And then the last one in the table is 2.5 pounds of meat, so 2.5 on the x-axis, and we're looking at 920 calories, so just less than halfway between 900 and 950. And then we're going to connect these just like we did for the last one. And now I know why the ruler doesn't work, because I can't hold the ruler and the microphone at the same time. So you're going to have to bear with me. And my line is not going to be very straight. Oh gosh. Okay. I'm going to have to fix that. If you hadn't noticed before, your teacher is a little bit of a perfectionist, and I'm going to have to go back and take care of that at another time. But I think you get the idea for now. So once again, they want us to examine the graph and note what we see. So if I'd used a ruler, we would see that that is linear. So we will note that the graph, whoops, let me fix my spelling. I'm hung up on the line that's not straight. So the graph is linear, meaning it is a straight line, or is supposed to be. And then like last time, I noted that if I were to extend the line, it would go through the origin, but this time I can see that if I were to extend the line, it would not go through the origin. So I'm just going to note that this graph would not pass through the origin. If extended. And once again, remember the origin is at 0, 0. So it would not pass through the origin. Okay, we're going to look at one more, and then the rest of this we will continue next Wednesday when we're all back together. So number 3, Sunset Splash and Spa charges an entrance fee of $5. So that's kind of like a flat rate that we saw back in Module 4. And then $2 per hour. They want us to complete the table. So this one's a little different. We got to complete the table based on what they just told us, and then graph the information to represent the situation. And they'll want us to label our axes. We did that for the previous problem. Before we graph and draw a straight line, well, I'll do the best I can. You can draw the straight line if we can connect those points. So for 0 hours at the spa, it's actually going to cost us $5 because of that entrance fee. And then if we're at the spa for 1 hour, remember it's $2 per hour, so that'll be $2 plus the $5 entrance fee, so we're looking at $7 total. If we're there for 2 hours, that's 2 hours at $2 per hour, so $4 there, plus the $5 entrance fee, so $9. 3 hours at the spa would be $6, plus the $5 entrance fee, so $11. 4 hours would cost $8, plus the $5 entrance fee, which is $13. And 5 hours would cost $10 plus the $5 entrance fee, so $15. So when I go to label the axes, of course, I will label the horizontal axis X and vertical Y, but we'll put the time on the horizontal X-axis, and I'm going to just note that that is in hours. And you know what, now that I look at it, we could label our axis T instead of X because that's the variable they're using, but I'll leave it X for now. We don't want to confuse anybody right as we've started graphing. Our Y-axis will represent our cost, and I'm just going to note that that would be in dollars. And so now I graph my information. So starting at the origin, if the point is 0, 5, so in other words for 0 hours, I'm not going to move on the x-axis. I'm actually going to stay at 0, but on the y-axis I'm going to go up to 5, which is between 4 and 6. For 1 hour at the spa, so right 1, it will cost $7, and that's between 6 and 8. For 2 hours at the spa, we'll go right 2, and that's going to be $9 between 8 and 10. 3 hours at the spa, right 3 is going to be $11, so between 10 and 12. 4 hours at the spa, right 4 is going to be $13, so between 12 and 14. And for 5 hours, right 5, that's going to be $15, so between 14 and 16. And once again, my not straight line. This is a really bad example. Okay, but there's my line. And they want to know if cost and time are proportionally related and how we know. So you might be saying, yes, because it's always $2 per hour. But remember, I know if it's proportionally related if I can always multiply by the same number. So I'm going to multiply time by some constant value to get the cost. So 1 hour times 7 would give me $7. But 2 times 7 would be 14, and that's not how much it costs for 2 hours. So actually 2 times 4.5 would give me 9, and I can actually stop there because I have enough information to see that the cost and the time are not proportionally related. So again, we'll answer no, just like the last table, and we'll say there is no constant value that relates time and cost. So in order for it to be proportional, we've got to see that constant value, and we're not seeing that. A couple more questions on the next page. They want the independent and dependent variables. So the dependent variable is obviously the cost. So the cost that we will be charged at the spa depends on the time. So cost is dependent and time is independent. And of course, the question about what do we notice about the graph. So once again, I notice that the graph is linear, meaning it is a straight line, but I also notice that it does not pass through the origin. And we will stop there for now and pick this up, like I said, next Wednesday. So for the remainder of the period, you're going to be working on homework 5.2a, We completed that lesson on Monday. Make sure when you're working on the homework, you're using your notes from Monday. You'll also work on the section 5.1 review. Make sure you use your notes from 5.1A, B, and C. Both due next Wednesday.